You're standing outside on a winter morning. Maybe you're waiting for the bus, or walking to your car, or just taking out the trash. The cold hits your skin, and within minutes you feel it, that unmistakable pressure in your bladder. You need to pee, and you need to pee now. Here's the strange part. You haven't had anything to drink in hours. Your body shouldn't need to get rid of excess water. So why does the cold make you feel like your bladder is about to burst? This isn't just in your head. It's a real physiological response that happens to almost everyone. And the reason why reveals something fascinating about how your body protects itself when temperatures drop. What your body is actually doing. To understand this, we need to talk about what your body is constantly trying to do: maintain balance. Your body has about 5 liters of blood flowing through your veins and arteries at any given moment. That blood needs to reach every part of you, from your brain down to your toes. But here's the thing. Your body has priorities. When you're warm and comfortable, your blood vessels are relaxed. Blood flows freely to your skin, your fingers, your toes. This is why you might notice your hands look a little pink or red when you're warm. Your body is letting blood hang out near the surface because it's safe to do so. But the moment you step into the cold, everything changes. Your body immediately recognizes a threat, not a predator or a danger in the traditional sense, but a threat to your core temperature. Your brain, your heart, your lungs, your vital organs need to stay at about 98.6 degrees Fahrenheit to function properly. Drop below that, and things start to go wrong. Drop far enough, and you die. So, your body makes a decision. It constricts the blood vessels near your skin, especially in your arms and legs. It's pulling blood away from your extremities and redirecting it toward your core. This is called vasoconstriction, but what it really means is this. Your body is choosing which parts of you matter most. The domino effect. Now here's where it gets interesting. When your body pulls all that blood from your arms, legs, and skin back toward your core, suddenly there's more blood in your central circulation than there was before. Your heart and the blood vessels around your vital organs are now dealing with more volume. Your body detects this increase, and to your kidneys, more blood volume looks like you've had too much to drink. Think about what happens when you chug a big bottle of water. Your body recognizes the excess fluid, and your kidneys start filtering it out, producing urine to get rid of what you don't need. That's exactly what's happening here, except you haven't drunk anything. Your body is just redistributing the blood you already have. Your kidneys can't tell the difference between "we have extra fluid" and "we centralized our existing fluid." All they know is there's more blood flowing through the core than usual, so they do their job. They filter out the excess and send it to your bladder. This is called cold diuresis. Diuresis just means increased urination. Your body is literally creating urine from your own blood volume because it thinks you have too much fluid, when really you just have more fluid in one place. The evolutionary logic. You might be wondering, isn't this kind of a design flaw? Why would your body get rid of fluids when you're cold when staying hydrated seems pretty important? But from an evolutionary perspective, it makes perfect sense. Imagine you're an early human caught outside in freezing temperatures. Your body's #1 priority isn't staying hydrated. It's keeping your core warm enough to survive the next few hours. If your blood is spread out trying to warm your fingers and toes, you're losing heat fast. But if you pull all that blood inward, you can maintain your core temperature much longer. The trade-off is that you'll need to pee, but that's a small price to pay for keeping your brain and heart functioning. You can find water later. You can't undo hypothermia. There's also another benefit. Urine is water, and water is heavy. If you're trying to stay warm and potentially need to move quickly, carrying around a full bladder of liquid that's not essential to your immediate survival is just extra weight and energy expenditure. Your body streamlines itself, keeping only what it absolutely needs in that moment. The modern experience. Of course, most of us today aren't fighting for survival when we step outside in the cold. We're just walking to our car or standing at a bus stop. But our bodies don't know that. They're still running the same ancient programming. This is also why you might notice you pee more at night during winter, even when you're in bed under blankets. Your core temperature naturally drops slightly when you sleep, and if your bedroom is cold, that drop is more pronounced. Your body responds the same way: vasoconstriction, centralized blood volume, and the signal to your kidneys to start producing urine. It's also why swimming in cold water makes you need to pee almost immediately, even more than just being in cold air. Water pulls heat away from your body much faster than air does, so your body constricts those blood vessels even more aggressively. More constriction means more blood centralized, which means even more urine production. The bigger picture is how it reveals something deeper about how our bodies work. We like to think we're in control. We make decisions, we choose what to do, we believe we're running the show. But underneath all that, our bodies are constantly making choices without consulting us. They're monitoring temperature, blood flow, fluid balance, and 1,000 other variables, making split-second decisions about how to keep us alive. You don't decide to constrict your blood vessels. You don't choose to produce more urine. These things just happen, and you only become aware of them when you feel that pressure in your bladder. It's a reminder that we're not separate from our biology. We are our biology. And our bodies carry within them the wisdom of millions of years of evolution, still responding to cold the way our ancestors did, still prioritizing survival in ways we don't even notice until we stop and pay attention. So the next time you're standing in the cold and suddenly need to pee, you'll know exactly what's happening. Your body is pulling blood inward, protecting what matters most, and politely informing you that you've got some excess fluid to get rid of. It's not convenient, but it might just save your life.